All right, so these notes are on the first derivative test. And what we're trying to do here is find relative extrema from doing this first derivative test. So let's say we're looking at this problem here, and we're trying to find the relative max, relative min from this problem. Well, there's a few things you want to do. If we're going to make it really quick and easy, there's a few things you want to do. Find the derivative. Set the derivative equal to 0 or undefined, which will give you your critical numbers. And then you're going to want to make a number line. And analyze basically that number line. Analyze that number line. That's pretty much what you want to do. So let's go through that process together on this one. All right, so the first derivative test is pretty straightforward. We want to go through these four steps. So find y prime. That's pretty much just cranking it out. So f prime of x is going to equal, I guess, just 1/2. And then derivative of sine is cosine, so negative cosine of x. And we're going to need to set that equal to 0 or undefined. We know that cosine kind of looks like this, so like it's never really undefined. Cosine is pretty much a continuous, smooth function. It's all good. So this is never undefined, but it does equal 0 sometimes. We need to know when cosine of x is equal to 1/2. That's really what we want to know. They did give us an interval here, a world that we're working with, which is 0 to 2 pi. So that means we really just need one rotation where cosine of x is equal to 1/2. Cosine is adjacent over hypotenuse, so we probably want this triangle here, this guy, which I guess is pi over 3. So I think that x is going to equal pi over 3. That's going to be one answer. And then I think probably not 2 pi over 3, because then cosine will be negative in that quadrant. So all students take calculus. So I think it's going to be 5 pi over 3, if I'm not mistaken. I could be wrong, but it's probably not. I'm probably right. So we got pi over 3 and 5 pi over 3 for our critical numbers. Now what we want to do is make a number line. So I guess we could say that this is done and this is done, all in red. Now we're going to make a number line, and we're going to use the number line to help us understand what's happening. So I think what I did was I made a nice little number line here. I want to talk about some subtleties with this as we're doing it. So these guys go on our number line, pi over 3 and 5 pi over 3. They must go on our number line. We must label our number line with a y prime, because that's what this number line is all about. These numbers are coming from the derivative. They're about the derivative. That's what we're studying. These are our critical numbers, so I'll just put these in a bubble over here. Now we want to pick some numbers that are in between here that make some sense. I don't see why we can't pick like just 2 pi over 3 maybe. 2 pi over 3 here. And maybe even 2 pi will be okay to use here, and 0 will be okay to use here. And we got to plug those into the derivative, which is this right here. So I guess 1/2 minus cosine of 0. Cosine of 0 is 1. So I think we're going to have a negative here, 1/2 minus 1. What's cosine of 2 pi over 3? Cosine of 2 pi over 3. Well, I think that's going to be negative 1/2. So we're actually going to have 1/2 minus negative 1/2. So we're actually going to have 1, which is a positive. And then here, when we put in 2 pi, again, I think it's going to be the same, because cosine of 2 pi is also 1. So it's 1/2 minus 1. So this is what we have. Now, a couple of important key points. The first thing I want to make a point of is that you labeled your number line y prime, because these numbers right here in red came from the derivative. And these numbers here are also being plugged into the derivative. And these plus and minus signs are about the value of the derivative. So this number line's all about that derivative, okay? Now we need to analyze that. So basically, from 0 until pi over 3, we're decreasing. And we're also decreasing from 5 pi over 3 until 2 pi. Remember that we're just going until 2 pi. We're increasing from pi over 3 until, whoops, not union, until 5 pi over 3. So what I want you to do is just kind of visualize what's happening. We're going down, then we got a flat part, we're going up, then we got a flat part, then we're going down. So this is kind of what it looks like. So where do we have a local max and where do we have a local min? Well, I guess the following is going to be the case. I want to type this out because I want to make sure we understand how important it is to explain your number line. So here is the conclusion. Okay, we have a local max. And I'm going to give you the point for the local max. So the local max is at 5 pi over 3, comma, I need a y value for that. And I need a local min. That's going to be at pi over 3, comma, and I need a y value for that. Now, before I do that, I'm going to get a y value for these in a second. Am I going to get the y value from the derivative or from the original function? Well, from the original function, right? So this is an important sentence. So let me see how I can make this really, really jump out at you. I'll make it bold and red. Since y prime goes from positive to negative, this is a very important thing to have here, okay? So let's underline that. You can't emphasize how much important that is, okay? And then we want to kind of do the same thing here, since y prime goes from, but in this case it's negative to positive, okay? So this sentence needs to be there. You have to have that. Now the thing is we need y values for both of these. Local min is really technically a point, isn't it? So we need a y value that goes with these. So I need to take pi over 3 and 5 pi over 3 and plug them into the original function, which is 1/2 x minus sine of x. 1/2 x minus sine of x. So let's do it. We got 1/2 x minus sine of x. That's what y is equal to. So if we plug in pi over 3, we have, I guess we have 3 pi over 2. Is that right? No, that's not right. We have pi over 6, I think. So we'll have pi over 6 minus sine of pi over 3. Sine of pi over 3 is, I think, root 3 over 2. So that's my first y value. That's what's going to go. This right here is going to go right there. Okay. Now I'm going to do my other one. Okay. This guy. I need the y value, the actual maximum. It should hypothetically be higher than the blue. So y is equal to 1/2 x minus sine of x. Remember, we're plugging into the original now. I'm going to plug 5 pi over 3 into that. I think when I plug in 5 pi over 3, I get 5 pi over 6 minus, all students take calculus. The sine value is going to be negative there. So I'm going to minus negative root 3 over 2. So I'm going to add root 3 over 2. So this goes there. And that's our local max. You can see that it's clear that the green is higher than the blue, right? It makes sense logically. So that's our local max, the green point, which is 5 pi over 3, comma, that mess right there. And then the local min is pi over 3, comma, the blue mess. All right, so we were pretty thorough and we went through that in a lot of detail. But now I'm just going to talk about a couple more problems where we're finding relative extrema. So what I want to do is analyze this problem right here, okay? Let's check it out. All right, so breezing through this problem, we know we need the derivative, so I'm going to look at f prime of x real quick, which is 2/3, leave the inside alone, and then chain rule that in just a moment, so that's going to be times 2x. So if you look at just the derivative real quick, you have 4x over 3, and then you have cube root of x squared minus 4, right? That's what y prime is equal to. And now you have to say to yourself, okay, well, what are my critical numbers? My critical numbers are as follows. 0, x equals 0, because you set the top to 0. So I want you to do the following. I want you to set the top equal to 0, And I want you to set the bottom equal to 0. Well, the bottom is going to equal 0 when x is equal to 2 or negative 2. So x equals 2 and x equals negative 2 are also critical numbers. So you're going to make a number line. But be aware of a couple of things. Kind of be aware of like if a point even exists in your original function. Like you got to look at the domain of your original function. Your original function here has a domain of all real numbers. It looks like it's okay. But sometimes that's not the case. So watch out. Like if it's a square root, it doesn't go for all real numbers. If it's a log, it doesn't go for all real numbers. So set the top to 0, set the bottom to 0, make a number line like so, with negative 2 and positive 2 and 0. We know we have a 0 derivative here, an undefined derivative here and here, and then make your number line. I'm going to stop on this problem and keep going because I think you can make the number line and draw conclusions based off of the last example. I want to show you just some different things you might be up against. So this one right here, finding the extrema, let's talk about the domain of this function. Like right away, what is a number that doesn't really work for this function? What is a number that you put into this function and this function has big issues? Well, you cannot put x cannot equal 0. So you have to go from negative infinity to 0 and 0 to infinity and realize that 0 cannot possibly be a max or a min. It's not even a thing. It doesn't even exist in this function. So please don't tell me that the functions has a max or a min at 0 because there's an asymptote there. You can't make a max or a min at an asymptote. So be aware that anytime that you have a domain restriction, any domain restriction will always show up on your number line. This is going to show up on your number line. So I can make my number line and I can put a 0 on it right now. I know it's going to show up on my y prime number line. Okay? So when we do the derivative of this, let's just kind of do it. 4x cubed, derivative of the top, times the bottom, minus derivative of the bottom, times the top, all over the bottom squared. Well, you'll notice the following. You'll notice that, again, here it is. When you set the bottom to 0, x equals 0 is going to show up on our number line. So x equals 0 is a critical number. Okay? That whole top is basically a polynomial. You should be able to set that equal to 0 and solve pretty easily, and then take it from there. So I want you to finish up these problems, these two, basically. So this video, I'm trying to keep it on the shorter side. I won't give an additional assignment with it. So finish up this problem here. So just try to wrap them up, see how they go. And then I want to talk a little bit about motion. And this problem I'll do together with you. But I do want you to I encourage you to pause the video and try this problem. So I'm encouraging you to pause the video and try it, but you don't have to. Okay, so trying to keep the video to a reasonable length, we've got an object that's launched upward. We know this is the function, s of t is equal to negative 16t squared plus 48t. Remember now, what do you always do in calculus class? You just take the derivative. Right? You know that it's probably a good place to start. So we have our derivative is this, and we want to set it to 0 or undefined. Because it's a polynomial, it's never going to be undefined. So that's good. So you have negative 32t equals negative 48. You have t equals, I think, you can make these positive. 48 over 32, is that 3 over 2? I think it is. 48 over 32 should be 3 over 2. So we're going to make a number line. I think if you do like negative b over 2a right here, negative b over 2a, you'll still get that 3 over 2. You'll know that this is the vertex point. So 3 over 2 makes sense in this problem. This is y prime again. So just plug in a number that you like. Plug in 0. Plug in 0 to the derivative. Plug in 2 to the derivative. So what's the derivative? Well, the derivative is this. When you plug in 0 to that, you get a positive. The object's moving up, sloping up. When you plug in 2, you get a negative, right? You plug in 2 here, you get a negative. So you know that this is where the object's max is. This is where the object is going to be maxing out. It's going to the max is going to be 3 over 2, comma, and really what you should do is you put 3 over 2 into the original to get the actual maximum height. And you'll have that answer. So that's what you need to do here. And that's pretty much it. So we'll wrap it up there. Hopefully this made sense, and I will see you soon. Peace.